So a perfect square is a number whose square root is a whole number. So what is the square root of 4? 2. So this is a perfect square. What's the square root of 36? It's a whole number. 6 times 6 is 36, right? So this is a perfect square. Can someone give me another example of a perfect square?
144.
144? Well, let's check. What's the square root of 144? 12. Yes. So there's a list of all the perfect. Okay, so these are all perfect squares. You're going to tell me what is the square root of 289. I'm looking for two positive numbers that you multiply together to give me 289. What is it?
17.
17 times 17. This is factored, right? Remember I told you factoring is the opposite of expanding. Factoring means that you're finding two things that you multiply together to get to the answer. 17 times 17 is 289. What's the square root of x squared? What times what gives you x squared? X. Right? You are factoring right now. You are finding two things that multiply together to give you the original question. What's the square root of 4x squared? What's the square root of 4? Do it in parts. What's the square root of 4? What times what gives me 4? What times what gives me x squared? So that's the answer. 2x times 2x. That gives you 4x squared, right? You're breaking it apart. You're looking for two things that you can multiply together to get you the original question. What's the square root of 25?
5.
What's the square root of x squared? X. So 5x times 5x gives me 25x squared. So we have x times x equals, someone else, x squared. X times negative 3, negative 3x. 3 times x is positive 3x. And positive 3 times negative 3 is negative 9. What happens now? What happens to this? Negative 3x plus 3x is what? What's negative 3 plus 3? 0. What's 0 times anything? 0. So how would I simplify this? What would I write?
X squared minus
-9.
That. Try the next one. See if you can notice a pattern. This is A. Let's see. What was B? Let's try it. A times A is A squared. A times positive 5 is positive 5A. Negative 5 times A is negative 5A. Negative times a positive is a negative 25. Do you notice a pattern happening here? What happens to this? Positive 5 take away 5 is 0. So what's the answer? A squared minus 25. Do you notice something? Both of these are something squared minus a number. Go back and look at the original question. Look here, everyone. I'll let you copy it after. This is a squared, and this is 25. Is this a perfect square? Yeah, what times what gives you 25? Look at the question. Is this a perfect square? What times what gives you 9? 3. You guys seeing a pattern here? Let's try the next one. This was a difference of squares. This is a perfect square, and this is a perfect square. If I give you a difference of squares and I tell you to factor it, can you factor it in your head? Let's break it down. What's 2m times 2m? 4m squared. What's 2m times negative 7? Negative 14m. What's 7 times 2m? Positive 14m. What is positive 7 times negative 7? Negative 49. What happens in the middle here? Negative 14 plus 14 is 0. So what's your answer? 4m squared minus 49. Notice a pattern. We have a 2m and a 2m. We have a 4m squared. We have a positive 7 and a negative 7. We have a negative 49. Notice how this gets canceled out in the middle? Is there one more? All of these answers were separated by what symbol? What operation?
Negative.
What operation is that? Adding, subtracting, what is it? What does this mean? Do I add or do I subtract? So this is called a difference, right? When you subtract, you're finding a difference. And the first two terms were, the first term and the last term were what? Perfect squares. These are called a difference of squares. It's the title. If I give you a question that is a difference of squares, you have to recognize this if a difference of squares. Is it separated by subtraction? Okay, if it's separated by subtraction and if it has two terms only, so yes, this has two terms, it's separated by subtraction, and this is the important part. Both terms are perfect squares. So I want you guys to copy this down. So to figure out if it's a perfect square or not, you're going to use the square root button on your calculator, and if the answer is a whole number, then yes, it's a perfect square. Okay? So is x squared a perfect square? Yeah. Is 36 a perfect square? What times what gives you 36? Okay. So if you're given a question like this, and I say factor, you're looking for two things that you would multiply together to get us the answer. Well, what times what gives you x squared? So I know that the first two terms have to be x, right? And we're trying to figure out what times what would get us back to 36. What times what is 36? 6, right? We're looking for two things that multiply together to get us to this question. How do we get a negative? Your answer is always going to be a negative, so a positive and a negative will give us a negative. That's it. That's factored. So, okay. So it only works this way. You can only do this if it is a difference of squares. And how do you know if it's a difference of squares? I just went over it. You see if all of these apply. Is it separated by subtraction? Are there only two terms? And are both terms perfect squares? If so, then that's how you factor it. Based on what you just learned, we are going to factor all of these. Do a quick glance. Are they all separated by subtraction? Okay, that's the first rule in difference of squares. Do they all have two terms? Yes, that's the second rule in difference of squares. Are all of the terms perfect squares? If I were to find the square root of each term, am I going to get a whole number? Yes. What's the square root of 81? What's the square root of 9? 3. What's the square root of 4? What's the square root of 25? 5. Square root of 36? 6. Square root of 49? 7. Square root of 16? 4. Square root of 100? All of these are difference of squares. So how do we factor a difference of squares? You're looking for two things that multiply together to get us the answer. So what do we have to do? How do I factor this? What's the square root of x squared? So x times x will get me back to the original question, right? What's the square root of 81? So 9 times 9 will get me back to the original question, right? What do the two symbols in the middle have to be? One has to be positive, one has to be negative. Does it matter if I write negative and positive? No. That's it. That's your answer. You factored it. Try all of them on your own and I'll take them up. So for all of them, you're looking for two things that multiply together to give you the original question. So you find the square root of each term and you separate them. You put one as positive and one as negative. One is positive and one is negative. It doesn't matter what order you put it in, but we know that it has to be a positive times a negative because all of them are separated by negatives. Now all you have to do, find the square root and fill in the answer. That's it. If it's in this order, 9 take away m squared, then I have to put, what's the square root of 9? I have to put 3 first, because that's the first term in the question, and then I put m second, because that's the second term in the question. That's it. That's the answer. 3 plus m times 3 minus m. Okay? Square root of 4 is 2. Square root of p squared is p, so that goes first. And then the square root of 25 is square root of 25. What times what is 25? 5? 5. So the answer is 2p plus 5, bracket 2p minus 5. Raise your hand if you got that one right. Okay, next one. Square root of 36 is 6. Square root of a squared is a. What's the square root of 49? What's the square root of b? So the answer is 6a plus b, 6a plus 7b, and 6a minus 7b. Raise your hand if you got this one right. Good. Square root of 16 is 4. Square root of n squared is n. Minus, what's the square root of 1? What times what gives you 1? 1. So 4n minus 1, 4n plus 1. It doesn't matter if you wrote 4n plus 1 times 4n minus 1. I don't care what order you write it in. Okay? And the last one.
That's wrong.
So it would be y plus 10, y minus 10. You're given a rectangle. We need to factor it because we're trying to figure out what times what gives me this. If the area of the rectangle is x squared minus 144, well, factor. Is this a difference of squares? Is it separated by subtraction? Are the two terms perfect squares? So what times what gives me x squared? What times what gives me 144? One has to be positive, one has to be negative. That means the length of this rectangle is represented by x plus 12, and the width of this rectangle is represented by x minus 12, because x plus 12 times x minus 12 gives me that. If x equals 20, what was it, centimeters? If x was 20 centimeters, what are the actual dimensions? Well, what's the actual length going to be? If x is 20, what's the actual length? 20 plus 12, right? What's 20 plus 12? So the actual length is 32 centimeters. What's the actual width? 20 minus 12. 8 centimeters. Does everyone understand what I did there? So then you tell me, I'm going to add this question. Oops. What is the actual area equal to? How do you find area? Length times width. What's the actual area? What's 32 times 8? 256 centimeters squared. That's the actual area.